Okay, this video is actually on page 129 of your notes, and since we're done with ionic bonding, we're not done, we'll come back to it, but we're going to talk about covalent bonding. Okay, so let's talk about a few things. Before we studied elements like neon, copper, sodium, metals, nonmetals, okay? In last unit we studied ionic compounds, metal and a nonmetal going together. So something that loses an electron and something that gains an electron making a compound. But what about like things like water, right? Hydrogen's not a nonmetal or not a metal. So you have a nonmetal and a nonmetal, okay? And this structure is going to be called a covalent bond, okay? So instead of gaining and losing electrons in a covalent bond, we're actually going to share electrons, okay? And there's going to be no charge on this atom or this molecule, just like an ionic bond, okay? So this is going to be a neutral group of atoms joined together by covalent bonds, sharing electrons instead of losing and gaining, okay? We can have diatomic molecules. Di means two, okay? And these are elements that make diatomics in nature, meaning you never see these elements as just one atom. You always see them combined together, okay? And those elements are, and you need to have these memorized, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And actually an acronym to remember these is Hofbrinkel, okay? So, meaning H is not just H in nature, it's H2, two hydrogens together. Oxygen is just not oxygen, or O, it's going to be O2 in nature. Fluorine is going to be F2, etc. Okay, so make sure you know those. And we say Hofbrinkel to help us remember those. And then we can have a molecular compound where we're going to have more than two elements in a compound. Okay, so molecular compounds tend to have lower melting and boiling points than ionic bonds because there's less attraction between the molecules. Meaning, they have to share that electron and they're not having that losing and that gaining that's forming that tight structure in an ionic compound. Okay? So, there's different ways that we can show a covalent compound. And those are the molecular formulas that we're going to talk about. Okay? So these formulas show how each atom of the molecule are attached together. And it's not a ratio like ionic. You know how we would crisscross and then reduce the charges for ionic? We don't do that in covalent. There's no reducing going on here. Okay? So like for instance, this would be F2O2, which then got reduced to FeO, and we don't do that. So like for example, H2O is water, H2O2 is hydrogen peroxide, H2O2 and HO are completely different compounds, okay? So I'm not going to reduce that. And then C2H6 is ethene, which we're not going to reduce that either, okay? Because C1H3 are completely different compounds, okay? However, a molecular structure or a molecular formula does not show us what the atom actually looks like. It only shows us what is inside of the compound, okay? So this is a molecular formula for something like NH3. Okay, we also can have this thing called a space-filling model, which shows us how much space each atom is going to take up, right? So if you remember, nitrogen's going to be small, well, hydrogen's the smallest atom on the periodic table, okay? So nitrogen's going to be big compared to hydrogen, okay? So we're going to have a nitrogen with 3 hydrogens attached, okay? And that's kind of going to be our space-filling molecule. We can also have a structural formula, okay, which shows the sharing electrons by lines, okay, and you probably have seen something similar to this before, and that's a structural formula, which we're going to learn how to draw these, okay? Call them Lewis dot structures as well. And then you can have a ball and stick model, which we'll eventually get to a lab where we're talking about ball and stick, but if you've seen these models before, we basically take something that represents a nitrogen and hook 3 hydrogens to it to show that they're actually sharing their electrons. Okay, so with that being said, let's go ahead and talk really quickly about covalent bonding and what it means, and I'll do a couple of examples, but we'll do a lot of these in class. If you remember, in ionic bonds, elements want to have 8 electrons like the noble gases. Same thing is true in covalent bonding. Okay? In covalent bonds, electrons share their electron, or atoms share their electrons So each atom within that molecule has 8 electrons, okay? Except for hydrogen, right? Because hydrogen wants to be like helium, and helium only has 2 protons, which means it can only have 2 electrons, okay? So it has that filled 2 electron shell. So hydrogen gas will actually, so one hydrogen has 1 electron, and another hydrogen has another electron. Therefore, their bond would look like something like this, and that would be our structure for hydrogen, okay? So our first thing we're going to talk about is single covalent bonds, and single covalent bonds are bonds that are held together by 2 electrons only. Each line represents 2 electrons, so a single covalent bond is a bond where there's 2 electrons being shared between 2 different atoms, okay? Such as hydrogen, which I just gave you an example for. Okay, so let's look at a couple of these. All right, fluorine is going to be our first one, okay? How many valence electrons does fluorine have? I hope you said 7, and it does, so I'm going to go 1, 2, 3, 4, 5, 6, 7, okay? And since I have 2 fluorine atoms, I'm going to have another fluorine that's going to be 1, 2, 3, 4, 5, 6, 7. Okay, now this is kind of easy to see because each fluorine has a single electron that can be shared with the other fluorine. Okay, so what's going to happen is fluorine is going to share these 2 electrons, and so I can rearrange it to make it look like this, to where the fluorines are sharing their electrons. Okay? You can also illustrate the sharing of the electrons by a line, but when you do that, you need to make sure that fluorine also gets its Lewis single, or its bonded Lewis electrons around the outside. Okay, that's fluorine. Water, which you've also seen. Now typically, the first atom is going to be the atom that's in the center, the central atom, except for when you have hydrogen out front, right? Hydrogen can't be a central atom. Why? Because it can only share 1 electron, right? So we need something that has more electrons available to other atoms inside of the molecule. So in this case, oxygen is going to be our central atom. So we're going to have oxygen with its 6 valence, because it's in group 16. And hydrogen is going to have 1 valence, right? Now, I want you to pay attention to this. It's kind of like a puzzle. Oxygen has a space here for 1 hydrogen that can be shared, and a space here for another hydrogen that can be shared, okay? So our water molecule is going to look something like this. It's going to have a hydrogen sharing 1 electron, and then 2 lone pairs. And if I wanted to do the line, I could do something like this. Hydrogen with oxygen's 2 lone pairs. Good? All right, let's do one more. Nitrogen with 3 hydrogens attached, okay? So I'm going to have nitrogen. Nitrogen has 5 valence electrons, like that. And would you look at that? There's 3 lone pairs of electrons on nitrogen, and hydrogen is going to contribute 1 electron apiece. So I can put hydrogen here with its 1, hydrogen here with its 1, and then hydrogen here with its 1. And they're all sharing those electrons. So if I was to draw this like with lines, the lines each represent 2 electrons, so an NH3 molecule will look something like this. Okay? So go ahead and try the last 3. And then we'll discuss this more in class. Thanks.